Hi everyone, welcome to today's GCSE revision video. There's 4 days to go to your GCSE Maths exam, and today we're going to do a recap of the statistics or the probability or data handling topics. So we're going to do a recap of those topics today. It might be quite useful to have pen and paper ready to write down some of the key information to remind yourself, or just sit back, relax and enjoy it. So let's get started.
Hi, today we're going to be doing a recap on the statistics topics for the GCSE Foundation course. So I'm using the Corbettmaths Revision Checklist and I'm just going to quickly go through each of those topics. If you want more detailed explanations on any of these topics, if you go to the Ultimate GCSE Foundation Revision video, if you watch from 6 hours, 47 minutes and 54 seconds until 7 hours, 55 minutes, that'll go through all these topics in a lot more detail. The purpose of this video is just a quick recap on each of them just to make sure you remember the key information for all of them. So let's get started. So on the Corbettmaths Revision Checklist, the topics that are in orange, so the ones that are in orange font, are the statistics topics. So you've got tally charts, frequency trees, two-way tables, all the way to samples, and we've got things like probability, scatter graphs, pie charts, combined mean, estimated mean, Venn diagrams, things like that. So let's get started. Okay, so let's start off by looking at tally charts. So tally charts, make sure you know how to complete a tally chart. So it might be that you know how many items are there and you've got to do the tallies for them, and make sure that when you get to the fifth one, it'll be 1, 2, 3, 4, and then the fifth one will go across, and then it'll be 6, 7, 8, 9, and then the 10th one will go across. So all the multiples of 5 will be going across. So make sure you know how to complete tally charts. Also, sometimes you might have tallies drawn for you or done for you, and you've got to write the frequencies. Remember, frequency means how many. So here we've got 1, 2, 3 on a Tuesday, so that's 3 there, and so on. So tally charts, hopefully it's quite a straightforward topic. Okay, next topic, frequency trees. So here we've got a frequency tree. It's important that you know how to complete them. So it might be that you've got some information in the frequency tree, like this one, and you might need to fill in this number. And if there's 40 people altogether and 23 had morning appointments, the rest, the other 17, must have evening appointments. In terms of this one, if there's 23 in the morning and 21 are on time, the other 2 would be there. So these two numbers need to add together to be that number, and so on. And here, if this is 5, there must be 12 there, because 12 plus 5 is equal to 17. So you might be asked to complete a frequency tree, and that's quite important. Also, you might be given questions where you've got to write down, for instance, what fraction of the morning appointments were late. So then that'd be 2/23 and so on. So make sure you're able to answer questions involving fractions and so on whenever you're dealing with frequency trees. Okay, next topic, two-way tables. So sometimes you might be given a two-way table and you've got to fill in some missing numbers. So for instance, here the art students. So in total there's 19 art students, and if 12 failed, that must mean that 7 passed. These two numbers must add together to be 19. Here, in terms of the students that failed, altogether 13 failed. So that means that 1 English student failed, because these two numbers need to add together to be 13, and so on. And then you do 25 plus 7 is equal to 32. Then you'd add these together to be 45. You could add these together to be 26, and so on. So completing two-way tables hopefully is quite straightforward, but also sometimes you might be given wordy questions. So make sure you know how to create your own two-way table and complete those as well. Okay, let's look at our next topic, pictograms. So pictograms, make sure you can complete pictograms and draw pictograms. A very important thing of pictograms is to make sure you know what the key represents. So here each circle represents 4 hours. So that means that half a circle would be 2 hours, a quarter circle would be 1 hour, 3/4 circle would be 3 hours, and so on. So in terms of powers here, it'd be 4, 8, and another 2 would be 10. So there'd be 10 altogether there for powers, and so on. So make sure you know how to complete pictograms and you know how to read pictograms as well. Okay, let's look at our next topic. Okay, our next topic, bar charts. It's very important you know how to read bar charts and also answer questions involving bar charts. So here we've got a bar chart. Up the side we've got number of ice cream sold. So going up the vertical axis would always be the number of items sold or the frequency, and so on, going up vertically, and then horizontally be what you're looking at, so each of the days here. And make sure you can read them. And whenever you're reading bar charts, it's important you know which each one of the little lines is worth. So here we've got 1, 2, 3, 4, 5 going up to 100. 100 divided by 5 is 20. So that's 20, 40, 60, 80. So that's 80 sold on Monday. So make sure you know the scale whenever you're dealing with bar charts. Okay, our next topic. Okay, next topic is frequency polygons. So if you encounter frequency polygons on your GCSE Maths, you might be asked to draw a frequency polygon. You might be asked to answer questions involving them. In terms of drawing them, if you've got a group frequency table like this, make sure you plot the frequencies in the midpoint of each of the categories. So here you'd go 10 across, 5 up, and then 30 across, 11 up, 50 across, 20 up, 70 across, 15 up, 90 across, 9 up. And then after you plot them, it would look something like that. And just make sure that whenever you draw your frequency polygon, you never join up the first one to the last one. You just do the first to second, second to third, and so on. So that's how you draw a frequency polygon. Also, make sure you know what the scale is. Very important. For instance, here, whenever we were plotting our frequency of 11, that we knew that each one of these little squares was 0.5, so it was going 0.51, and so on. And that's it. So make sure whenever you're drawing a frequency polygon, you're plotting the frequencies in the midpoint of the categories, if it's group data. If it's not group data, probability, then that's quite straightforward. Okay, so that's frequency polygons. Line graphs, so you might encounter line graphs, and obviously with line graphs, you've got your time going across horizontally, and then vertically is your frequency, or whatever you're looking at will be the vertical axis, but you'll have time going across with your line graph, and just make sure you're joining up the consecutive points with straight lines, like so, and that's a line graph. Okay, next, it's important you know how to draw pie charts and read pie charts. So in terms of drawing pie charts, if you were given a frequency table like this, make sure you know how to find the angles for each one of the sectors. So here, if I wanted to find the angle for England, France, Ireland, Scotland, and Wales, those angles, I would add up the frequency and find the grand total. In this case, it's 90. Then I would take 360 and I would divide it by the total frequency. So 360 divided by 90 is equal to 4. So each person is represented by 4 degrees. And then I would just multiply each of them by 4 in this case. So times by 4, times by 4, times by 4, and times by 4, and that would tell me the angles. And so here that would be 20 times 4 is equal to 80 degrees, 5 times 4 is equal to 20 degrees, and so on. And then you can get each of the angles. And if you want to, you can add up the angles at the end and check that they add up to be 360 degrees. And that's how you get the angles for drawing a pie chart. Now, in terms of drawing a pie chart, you'll often have the circle and that line drawn for you. And if that line's not drawn for you, make sure you draw a line going straight up to the top, and then just get your protractor and then measure each of the angles. So you'd start off, you'd measure the first angle, which was 80 degrees. You go around to 80 degrees, put a dot, draw a line through it, and that'll be the first sector. Then you rotate your protractor, so then it's on that new line, and so on. And then you just draw that pie chart. And make sure whenever you're drawing your pie chart, you label each of the sectors. So you'd label one of them England, one of them France, one of them Ireland, one of them Scotland, and one of them Wales. Okay, so that's drawing pie charts. In terms of reading pie charts, so here we've got 2 pie charts. We've got one for under 13s and one for under 15s. Now these are quite useful in telling us some information about the proportion of matches won and the proportion of matches lost. So in terms of the under 13s, they won a quarter of the matches and they lost 3/4 of their matches. And if you knew how many they played in total, you could work out how many they won and how many they lost. Likewise with the under 15s, in terms of this sector, it's 120 degrees. If you do 120 over 360 and cancel that down, cancels down to be a third. So that means that they won a third of their matches, and then that means they lost 2/3 of their matches. And again, if you knew how many matches they played, you could then work out how many they won and how many they lost. And one thing to note whenever you've got pie charts, if you've got 2 pie charts like this and you were asked, did the under 15s win more matches than the under 13s? Remember that the pie chart only shows the information in terms of what the proportion of matches that the under 15s won and the proportion of matches that they lost. So they won a third and they lost 2/3, but without knowing how many they played, you wouldn't actually know those actual figures. So in terms of, if you ask questions in terms of, did the under 15s win more matches than the under 13s, if you know how many matches they played, you can work that out. But if you don't know how many matches they played, you can only say they've won a larger fraction or proportion of their matches. Okay, our next topic, probability. So it's important to know your probability scale, where 0 is impossible, 1 certain, 0.5 is even chance, such as getting a tail whenever you flip a coin. Anything to the left of this is unlikely, and the closer to 0, the more unlikely it gets. And likewise, anything to the right of 0.5 is likely, and the closer to 1, the more likely it is to happen. So that's your probability scale. Now, it may be also you've got to write down probability. So for instance, if one of these letters is chosen at random and there's 12 letters, you might be asked what's the probability that the letter is an S. And if there's 12 altogether, it'll be 12 on the denominator. And because there's one S, it'll be 1 out of 12. So the probability of picking an S here would be 1/12 if you're picking one of the letters at random. So it's important you can write probabilities as fractions. Also, so in some situations, as decimals too. Okay, let's look at another question. So in terms of decimals, here we've got a 5-section spinner. So it's a 5-section spinner and it's spun. And this table shows us the probability. And now if it's a 5-section spinner labeled 1, 2, 3, 4, 5, it's certain to land in one of those 5 sections. So therefore, if you're asked to find this probability here, you know that these probabilities will all add together to be 1. So you could add these 4 together and take it away from 1 and find that probability. Okay, next, sometimes whenever you're dealing with probability, you might be asked to find the probability of something not happening. So if the probability of Hannah winning a competition is 0.28, you might be asked to find the probability that she doesn't win a competition. And to find the probability of something not happening, you take the probability of it happening away from 1. So you do the 1, take away the probability of it happening. So for instance, if I wanted the probability of Hannah not winning the competition, I would just do 1, take away 0.28, which would be equal to 0.72. The probability of her not winning would be 0.72. Okay, also with probability, sometimes we're probably asked to find how many times you'd expect something to happen. So if you want to find out how many times you'd expect something to happen, you take the number of trials. A hair factory makes 6,000 plates, and the probability of one's faulty is 0.0035. So if you're asked to find how many faulty plates you'd expect in a day, you would take the 6,000 plates that are made, that's the number of trials, and you multiply by the probability of it happening, which is, in terms of this case, the probability of it being faulty, which is 0.0035. And when you multiply multiply those together, that'll tell me how many times you'd expect something to happen. In this case, that'll be 21, so you'd expect 21 faulty plates. You may also encounter the term relative frequency, and the relative frequency is the number of successes over the number of trials. So if, for instance, we rolled a dice 100 times and we get 17 sixes, the relative frequency of a 6 would be 17 out of 100. 17 sixes out of the 100 times we rolled the dice. So relative frequency is the number of successes over the number of trials. Okay, next. You may be asked to list outcomes. So for instance here, Emily's making a pizza and she's going to choose 2 different toppings, and her choices are ham, chicken, olives and pepperoni. So in terms of listing her outcomes, make sure you work systematically. So do ham and chicken, ham and olives, ham and pepperoni. So we've done all the ones with ham. Now chicken and olives, chicken and pepperoni, and then olives and pepperoni. So make sure whenever you're listing outcomes, you're working systematically. You're not working around, you're not just jumping around randomly whenever you're doing your listing your outcomes. Okay, next topic. Our next topic is scatter graphs. So make sure you can plot points on scatter graphs and draw lines of best fit if you're asked to as well. And also make sure you know how to use a line of best fit. So if we were asked to estimate the value of a car that's 3 years old, we would go to 3 years old, we'd get a ruler and pencil and draw up to the line of best fit and across, and that's equal to £6,000. So make sure you can plot the points on scatter graphs, make sure you can draw the lines of best fit, make sure you can use your lines of best fit to read off values and make estimates. Also make sure you know when it's not really advisable to use your line of best fit to make estimates. So for instance, if I was asked to use my line of best fit to estimate the value of a car that's 20 years old, because that's beyond the range of the given data, then that wouldn't be sensible. So it's important you can plot points on scatter graphs, draw lines of best fit, also use your line of best fit and say when it's sensible to use your line of best fit. Also, you might need to talk about the types of correlation, so make sure you remember your positive correlation, your negative correlation, and what no correlation looks like as well. Stem and leaf diagrams. So in terms of stem and leaf diagrams, make sure you know how to draw your stem and leaf diagrams. So you're going to be doing them in order. So here we've got 31, 39, 40, 43, 46, 51, 57 and so on. Make sure if you're drawing a stem and leaf diagram, you've also got your key. So 3/1 means 31 minutes in this case. So make sure you know how to draw a stem and leaf diagram. Make sure it's in order. Sometimes it's useful to do an unordered one first of all, and then put it in order and get your stem and leaf diagram. And make sure also whenever you're drawing a stem and leaf diagram that you don't miss any one of the values. So in this case, I'd count them and check there's 1, 2, 3, 4, 5, 6 and so on. I'd count how many I've got and make sure that matches what I was given in the question. With stem and leaf diagrams, you may also be given questions like find the range. So in that case, I would do 75, take away 31 to find the range. So that's how I'd find the range in this case. I would do the biggest value, take away the smallest value. If I was asked to find the mode, the most common one, I would look here and I've got 57 and 57. So the mode would be 57. If I was asked to find the median, the middle value, I'd cross off the smallest, cross off the biggest, cross off the next smallest, cross off the next biggest, and I'd carry on until I would find that median, and then the one in the middle would then be the median. So 57 is also the median in this case. Also, you might be given questions, for instance, what fraction of students took less than 40 minutes. So you then say, well, 2 students took less than 40 minutes. This one took 31 minutes and this one took 39 minutes. I'd find out how many students there are altogether and then write that as a fraction and things like that. So make sure you're ready for that whenever you're dealing with stem and leaf diagrams. Also, in terms of our averages and our range, in terms of the mode, remember the mode is the most common value. So if you had a list of numbers like this and you're asked to find the mode, you just look and see which one appears the most. In this case, it would be 2 because it's 1, 2, 3 2s, and no other number appears that many times. So the mode is the number, the value that appears the most often. Okay, next, make sure you know how to find the median. So if you get a list of numbers and you want to find the median, you put them all in order and find the middle one, and that's the median. If there's 2 numbers in the middle, you've got to find the middle of those. So for instance, if I had 4, 7, 8 and 10, the median in this case would be 7.5 because you've got 2 numbers in the middle and you've got to find the middle of those for the median. And if you've got 2 of the same number in the middle, well, in the middle of 5 and 5 is 5. So to find the median, you just put the numbers in order and then find the middle value. Okay, next, to find the mean. To find the mean, you add up all the values and divide by the number of values. So if we wanted to find the mean of these basketball players, I'd add up all their ages, and then that's equal to 130. There's 5 of them. If I divide 130 by 5, that gives me 26. So the mean age is 26. So to find the mean, you add up all the values and divide by the number of values. You also sometimes asked to find the range, and the range is the largest value to subtract the smallest value. So here, if we wanted to find the range here, the greatest number of shots taken was 7. The smallest number of shots taken was 2. So if I do 7 take away 2, that's equal to 5. So the range of the number of shots taken would be 5. So the range is the biggest value, take away the smallest value. Okay, now sometimes you're asked to find those averages for tables. So for instance, if you're asked to find the mode or the modal class from a frequency table, you look for which one's got the highest frequency. So here we can see there's 16 in between 20 and 30. So the modal class would be that class. So you just write that down. That's the modal class because it happens the most. If for instance, it was the ages of people and then you had one with the highest frequency, whichever age has the highest frequency, that would be the mode and so on. So the mode is just the one with the highest frequency whenever you're dealing with frequency tables or group frequency tables. Okay, next, the median from a frequency table. So if you've got a frequency table like this and you want to find the median, one approach is to list them all out if you really wanted to and you've got time. So here you could say, well, 2 people are 18 years old. Then you could say there's 3 people that are 19 years old and so on. And you can list them all out that way and find, write them all down and then find the median, cross them all off and find the middle one if you wanted to. Another approach, and probably the approach that I would use is I would use this n plus 1 divided by 2. If I take the total number of people and add 1 and divide it by 2, that'll tell me the position of the median. So in this case, if we add these numbers together, the frequencies, there's 19 people altogether. So if I want to find the position of the median, so if you line them all up in order and you want to find where the median is, I'll do 19 plus 1, that's equal to 20, divided by 2 is equal to 10. So the 10th person is the median. So the 10th person is not on there. So that's 5 people altogether. The 10th person's not on there. The next 13 people, yes, the 10th person will be in there. So that means the median in this case is equal to 20. I said you could list them all out, but if the frequencies are quite large, then that's quite time consuming. So n plus 1 divided by 2 helps you find the position of the median. And if you're given a group frequency table, so if the ages were 0 to 10 and 10 to 20 and 20 to 30, you might be asked which class interval the median lies in. And then depending on the frequencies, and it's an estimate anyway, some people use n plus 1 over 2 and some people just use n over 2 in that situation. Okay, next, the combined mean. So here we've got 20 students in class A, 10 students in class B. The mean for class A is 60 and the mean for class B is equal to 40, and we're asked to work out the mean test score for all 30 students. So whenever you're dealing with questions like this, it can be quite useful to know that if you take the mean and multiply it by the number of people, that'll tell you the grand total, because remember you would have added them all up and divided by 20 to get a mean of 60. So if we take 60 and multiply that by 20, that's equal to 1,200. So that's the total number of marks scored for class A. And then in terms of class B, there's 10 students in class B, their means equal to 40. So if we take the 40 and multiply that by 10, that's equal to 400. So there's 400 marks altogether in class B. So it's quite useful to know that if you've got the mean and you multiply by the number of people or the number of items, that'll tell you the total. And then you just add these together to get 1,600 and then just divide it by 30 and that'll give you the combined mean. Okay, next. Okay, our next topic is the estimated mean. So sometimes you might be given a group frequency table like this and be asked to find an estimate for the mean. And that's quite nice actually, because we don't know the actual values, but we can choose the midpoints and use those to find an estimate. So we can add on 2 columns, the midpoints. So a midpoint of 0 to 10 would be 5 years. A midpoint of 10 to 20 would be 15, 25 and 35, finding the midpoints of those. So there are midpoints. And remember, for the mean, we would want to add up all our values and divide by the number of values. So what we're going to do is we're going to multiply the frequencies by the midpoints to find our estimate for the grand totals for each of the categories to find our fx column. So we just multiply the midpoints by the frequency, so 45, 195 and so on. We then add up the fx column to get our estimate for the grand total, and then we add up our frequency to find out how many people there were. That might be given to you in the question sometimes, so you do 9 plus 13 plus 16 plus 2, and that's equal to 40, and then you divide the total fx by 40, and then that'll be your estimated mean. So you just get the midpoints, you then times those by the frequencies to find the fx column, add them all up to get the estimate for the grand total, and then divide that by the total frequency, and that's the estimated mean. Okay, next topic, Venn diagrams. So sometimes with Venn diagrams you might be given a situation. So you might be told there's 30 students in a class and 7 students like tea and coffee, so you put that 7 in the middle. You might be told that 10 students like tea altogether. Well, if 7 like tea and coffee and 10 like tea altogether, that must mean there's 3 in there, and so on. And then you would just fill in the Venn diagram and then just answer some questions on it. And I actually like those ones. And if you want more practice of those, is to practice questions on Corbettmaths. Also, you may encounter some notation whenever you're dealing with Venn diagrams. So for instance, if you've got a Venn diagram, this would be A and this would be B. And A with a little dash means the complement of A means not A. So on the Venn diagram in yellow here would be not A, it's anything outside of A. B dash means the complement of B or not B, so it'd be anything outside of B. A union B, that little U means union, that means A or B or both, so that'd be anything in A or B, so that's shown here in yellow. And A with this little N means intersect B, so that means A and B. So if you encounter this, it means union, it means A or B, and A with a little N shape means A intersect B, and it means A and B, it means in the middle, and that's it. So it's important to know that notation. Okay, tree diagrams. You may encounter tree diagrams on your GCSE Maths exam. At some point, you know how to complete those tree diagrams and how to answer questions on them. So here we've got a tree diagram with John and Dan and hitting and missing targets. So the probability of John hitting is 0.6, so the probability of him missing would be 0.4. In terms of Dan hitting is 0.7, so him missing would be 0.3, hitting would be 0.7, and missing would be 0.3. So once you've completed your tree diagram, you may be asked to answer questions involving it. So you might be asked, what's the probability that both of them hit the target? So to find the probability of a hit and a hit, and a hit, you multiply the two probabilities along the branches. So we would do 0.6 times 0.7, which would be equal to 0.42. So whenever you're dealing with tree diagrams, you multiply the probabilities on the branches. So a hit and a miss would be 0.6 times 0.3. A miss and a hit would be 0.4 times 0.7, and a miss and a miss would be 0.4 times 0.3, and that's how you'd find the probabilities. And then you might encounter questions like, what's the probability that both men hit the target? That'd be 0.42, or both men missing the target, 0.12. What's the probability that only one man hits the target? And then that'd be either that option or that option, so you then add those together because only one man hitting the target. It could be John hits it and Dan misses it, or John misses it and Dan hits it, so you'd add those together to get 0.46, or it could be at least one man hitting the target, and then that would be that option, and that option. Then you'd add those together if it's at least one man hitting the target, because either one could hit it or both could hit it, and so on. So make sure you know how to answer those tree diagram questions. Also, you might be encounter questions that involve reading tables, and that's video 387. If you want more practice on those, there's practice questions there. In terms of reading tables, just make sure you're reading it carefully. So for instance, if you're asked to write down the types of caravan that have decking, where you go to decking, and the luxury caravan has decking, but also the comfort caravan has decking as well. So make sure you're able to read those questions and then read those tables. Another topic you may encounter is samples. So remember, samples are just a selection of the whole population. So it's important that a sample is representative. So for instance, if I wanted to find out if students like school, I wouldn't necessarily just ask year 7 students in my class, because obviously they're going to love school. So make sure your sample is representative. So it would take a selection of students across year groups, maybe boys and girls in all different year groups and so on. Also, you might be asked to answer questions like this, where there's 480 students at a school. A teacher surveyed 50 students, asked them which colour of blazer they would like, a new blazer. So 20 of the 50 want black, 15 of the 50 would like navy, 9 of the sample of 50 would like green, and 6 of the sample of 50 would like maroon. And if the teacher wanted to estimate how many of the 480 students would like a navy blazer, well, 15/50ths of her sample, so you'd cancel that down as a fraction, and then that'll tell you what fraction of the students wanted a navy blazer, and then you could just work out that fraction of 480, and that's it. So in this video, I've given you a really quick recap of tally charts, so make sure you know how to plot them, and you know to do 1, 2, 3, 4, 5 and draw the line going across and so on. Make sure you can do your frequency trees, so you know how to draw them and answer questions on them. Two-way tables, you know how to complete them, and then you can maybe also draw them whenever you're given information. Pictograms, make sure you know what the keys were so that you can draw the pictogram and also read a pictogram. Bar charts, make sure you've got your frequency going up vertically and you know what the scale is, and make sure that all the bars are the same width and things like that. So bar charts. Okay, next, frequency polygons. If it's on group data, you can just plot them and make sure you join up the points. Don't join up the first one, the last one, only join the first, the second, the third, and so on. If it's group frequency, make sure you plot them at the midpoints. Line graph, again, just make sure you've got your time going along horizontally and make sure you join the points, the consecutive points. Pie charts, make sure you can draw pie charts to add up the frequencies to get the grand total. Divide 360 by that total to find the degrees per person, and multiply each of the frequencies by that to find the angle, and then just draw your pie chart. Also make sure you can read pie charts so you can answer questions, for instance, working out how many people, if for instance a quarter of them said yes, to work out how many that would be, and so on. And make sure you're also aware that pie charts just show you the proportion, and you would need to know the total to work out the values. Probability, make sure you know your probability scale, make sure you can write probabilities. Also, if the probabilities add up to 1, how to find some of the missing probabilities in tables, how to find out how many times you'd expect something to happen, also the probability of something not happening. Relative frequency, so the number of successes over the number of trials. List and outcomes, make sure you're systematic and you get them all. Scatter graphs, make sure you know how to plot the points, you know how to draw a line of best fit, and you know how to use your line of best fit, and when it's not sensible to use your line of best fit, and also your types of correlation, your positive correlation, your negative correlation, and your no correlation. Stem and leaf diagrams, make sure you know how to draw an ordered stem and leaf diagram, and make sure you put it in order, and make sure that you don't forget any of the values, and you've got a key as well. Make sure you can answer questions in terms of finding the range, the mode, the median, things like that. In terms of the averages and range, make sure you know what the mode is, the most common, the median, put all the values in order and find the middle value. If you've got 2 in the middle, find the middle of those. The the mean, add up all the values and divide by the number of values, and the range, the biggest value, take away the smallest one. In terms of the mode, make sure you can read a frequency table and find where the mode is, or the modal class interval. The median, know how to find the median from a frequency table, so use n+1/2 to find the position of the median, and then find that value. You could list them out if you've got time, but I would probably use n+1/2. If it's a group frequency table, you might be able to find which class interval contains the median, and then you can use n+1/2, or some people use n/2 because it's an estimate anyway. Next, the combined mean. So if you've got two different groups, how to find the combined mean. So multiply the mean of each of them by how many people are in each one of them to find the total. Then add them all up to get the grand total, and then divide it by the total number of people. The estimated mean, find the midpoints, times them by the frequencies to find the FX column. Add up the FX column and divide it by the total frequency to find the estimate of the mean. Okay, Venn diagrams. Make sure you can answer Venn diagram questions on wordy situations, but also make sure you know the notation that A union B means A or B, A intersect B means A and B, and an A dash means not A. Tree diagrams, make sure you know how to complete the tree diagrams by writing the probability along the branches, and make sure then to find the probabilities, you just multiply along the branches. So if for instance you wanted a hit and a hit, you'd multiply the numbers on those branches. There might be decimal numbers, so make sure you know how to multiply decimal numbers, but also there may be fractions, so make sure you know how to multiply fractions. Reading tables, just have some practice with reading tables and make sure you can read tables. And samples, and know when a sample's fair and when a sample's not fair, and make sure that it's representative. And that's it. So hopefully this has been useful as a very quick recap of the statistics topics. And a reminder, if you need some extra help in any of them, beside each of them, you've got the video number up here, but also you had the ultimate revision video, and the ultimate revision video is really useful for you in terms of going through those topics in a bit more detail. And that's it.
And that's it. So in this video, we'll focus on the statistics topics. I really hope you find this video useful. Remember to check back tomorrow, because tomorrow we're going to go through the algebra topics, and the day after the geometry and the shape, space and measure topics. So see you then. Cheers. Bye.